Good morning, ladies and gentlemen. Welcome to our webinar presentation on what we believe are the 4 key stages to a better sprinkler system. Today's presentation is to be split into 2 parts. My name is Dale Kinnersley. I will be presenting stages 1 and 2. I'm the principal consultant for the FPA, and as can be seen on the screen, my credentials are shown. Also shown is the second presenter, Mr. Ian Walters, who will be presenting stages 3 and 4, followed by some questions. As derived from the title, we've split this into 4 key stages to what we believe are the main areas that need to be focused upon to achieve a better sprinkler system. There are many other factors that can affect the sprinkler system at various stages throughout, and if these 4 stages are considered in detail, the robustness and compliance relating to the sprinkler system should provide confidence to all key stakeholders of the effectiveness and operability of the system. As an engineer and being involved in specification, there are questions we believe should be asked before pen is put to paper. Important questions that determine many future issues in addition to fitting in with the fire strategy. I'll go into these in more detail in the following slides. But from experience as an engineer within the industry, I've been involved in reading and proofreading specifications for many years, and it's at these stages that there's so many mistakes that have been found with regards to the sprinkler system. What is required of the sprinkler system? What standard is the sprinkler system to? Is it classified correctly? Have they taken into account the full height of the building? Have they taken into account who's involved? What stakeholders are involved? Does it need to comply? And are there any features or anomalies that may affect the specification or any part of the sprinkler system, which then may mean it does not comply? And these are key issues that need to be resolved early doors in the specification with key stakeholders to ensure that the specification is up to date. As I've said, being involved in the industry for over 30 years, I've read specifications that have stated that it should be to BSEN 12845, it should incorporate the technical bulletins, it should incorporate NFPA, it should be to BS 9251, and finally, the insurers must be involved. This doesn't really specify what the system is, so at the beginning, the ambition of the system, it needs to be derived straight away to ensure that the specification is correct for the risk. So moving on and going into these slides in more detail, what is the ambition of the system? Well, the ambition of the system is derived from why is the sprinkler system required? Is it required for life safety or is it required for property protection? Who's actually asked for the sprinkler system? Is it a legal requirement? Is it a legislative requirement? Is it to satisfy building control or the building insurer? These key details must be realised at the very, very beginning of writing the specification, because there is a major difference between the life safety requirement and property protection requirement. As can be seen on the right-hand side there, we've got the 2 different standards that the UK rule. So the correct design standard, it might be to an American standards where you've got NFPA, or if it's an insured business or building with FM Global, they will have their own FM data sheets. But most likely in the UK, if a sprinkler system is required for life safety or property protection, it falls into 2 categories. We have on the left hand side there, as shown on the screen, we have the BSEN 12845, which is a minimum standard. It is there for enhancing people to escape from the building before collapse. It's a minimum standard. And on the right hand side, we also have the LPC rules, which is more comprehensive. It builds on the base document of the BSEN 12845, and it adds on additional requirements that have been written by insurance experts and industry to enhance the sprinkler system to provide elements of property protection. So it's an overall standard that covers both the property and also life safety. And there are also I put on there on the slide, there is also a residential and domestic standard, which is BS 9251. Currently this is being modified, so there should be a new standard out later on in this year. I just thought I'd mention that, but with regards to this presentation today, we're going to be focusing more on commercial and industrial. So Moving down, the correct classification of the system. Well, this will depend on the building and its use, its construction, its height and other factors. As we can see there's many different types of classification of system. Light hazard, which limits compartment sizes to 126 square metres, and this would include offices, prisons and schools. In 30 years that I've been involved in fire protection and sprinkler systems, I've never actually designed a light hazard sprinkler system. Ordinary hazard, well, this is split into 4 areas. We've got ordinary hazard group 1, ordinary hazard group 2, 3 and 4. So an ordinary hazard group 1 risk could be a hotel, a school or a hospital. An ordinary hazard 2 risk could be a museum, a bakery or an abattoir. Ordinary hazard 3, which is probably the most common, we're talking department stores, so your shopping centres, office tower blocks, plant rooms. And ordinary hazard group 4, cinemas, theatres, cotton mills. Then we move into high hazard process. Is the building being used as a process building, normally a warehouse for production? This again is split into categories 1 to 4. So we've got category 1 could be print works, category 2 could be paint manufacturers, category 3 could be foam and plastic manufacturers, and category 4 firework factories. Then we move into storage. High hazard storage is normally warehouses. We also have high rise, buildings over 45 metres, and that's measured from the centre line of the pump to the highest sprinkler, or from the lowest sprinkler to the highest sprinkler, and this is pretty much replicative of high rise office buildings or mixed use buildings. As we've got there, mixture of classifications. This could be a building that's got maybe on the ground and first floor some retail areas. On the second floor to the 5th floor could be office, and from the 5th floor upwards could be residential. We've got mixed use buildings. So getting the correct classification of system for the risk is vital. Moving on, is the system required to meet compliance? Well, different standards have different requirements. For instance, the sprinkler system designed to meet building control for life preservation, which is the 12845, only requires 60-minute fire separation between sprinkled and unsprinkled compartments. So under the life safety standards, under the British standard, you can have permitted and necessary exceptions, such as enclosed staircases, washrooms and toilets that have got no storage in. So when you've got this scenario, fire resistance between compartments is only required to be 60 minutes. With regards to the LPC rules, this is slightly different. It provides a little bit more information, and it's in line with approved document B. And this may require higher levels of fire resistance, but this depends on the building, what the building is classified as, and the height of the building. And in most cases, the technical bulletin, which is TB 206 of the LPC rules, when buildings exceed 30 metres in height, there are no permitted exceptions. So on that basis, fire resistance must be what it is stated in the book, could be up to 2, 3, 4 hours, but there are no permitted exceptions. Water supply. Due to spatial limitations, these are normally compromised on the ability to store the correct quantity of water to suit the hazard classification and the height of the building. Water supplies are normally compromised because space is at a premium. Lots of office tower blocks have water supply capacities reduced and hope that the infill from the town's main can make up the difference, because they are stuck by the structural elements of the building and they're normally put down in basements. So has the water supply been compromised? Does the water supply fire pumps cater for the height of the building? Has it been properly thought about that maybe the height of the building is over 45 metres and you might need multi-stage pumps, therefore sectionalising your building into different sections so that each section is covered by a classification in terms of height between 0 to 15 metres, 15 to 30 or 30 to 45. And fire resistance, as we spoke about, that's another issue with regards to, like I say, the height of the building and what is required. The difference between life safety requirement and property protection requirement is quite different. So is the system going to comply? These are little incidental issues that need to be considered for compliance with the standard that is selected at the beginning. So this must be confirmed in the specification. Then we move on to stakeholder engagement. Has everybody with an interest in the building and fire protection been considered? The list shown is not exhausted, but those shown should always be involved in the specification of the sprinkler system. Architects very rarely like sprinklers. It's the service nobody wants to pay for. It's a grudge purchase, but it must be factored in to their design. Consultants, it's got to be with regards to everybody wants some nice lighting, carpets, walls, air conditioning, sprinklers. They've got to be designed in. And the sprinkler engineers, M&E engineers, they must consider this level of sprinkler protection that needs to be applied and comply with the standard. And most importantly of all, building insurers should always be involved, and the AHJs, the authorities having jurisdiction, they should all be involved, as well as the owner occupier of the system or the tenant of the building that's going to run the sprinkler system. Stakeholder engagement must involve all these people. And finally, features and anomalies. Recently, due to spatial separation issues in major cities, additional features such as window sprinklers have been added to the system to negate the need to increase fire resistance and glazing. Window sprinklers do not fall within any national standard. They're an added feature. They can also compromise the water supply requirements, which usually increases the capacity of the water requirement. So these additions are seen as an add-on to the sprinkler system. They won't form part of the compliance of the system, but they need to be considered. They may be there because they've reduced the fire rating of the glazing. A fire from a building adjacent may be needed to be considered. So these window sprinklers have been added on, and the requirement for them is based on American standards, and they have to be fully hydraulically calculated. They have to be run for 90 minutes, depending on the spacing of the window mullions. The spacing of the sprinklers needs to be considered. And when you move them closer or further away, you increase the pressure requirement of the head, which increases the flow. And this flow for 90 minutes needed to be added on to your sprinkler system. So again, while space is an absolute premium and everything's trying to be shoehorned into the smallest possible space, if you've got these requirements, it's only going to increase the requirement for stored water capacity. Therefore, engagement with the local water authority may be required, so that we can assume that, or we can test their water supplies to make sure that within the period of time that's required for the system, if it was ordinary hazard, it's a 60-minute stored water, the water that's used from the town's main can make up the difference if you've had to reduce the size of the sprinkler tank. These are all things that need to be considered in the specification to ensure that it's correct from the word go. Selection of third-party approved contractors. Not only third-party approved contractors, we've got sprinkler components as well. So it is essential in confirming their ability to deliver a sprinkler system that your contractor is a member or a scheme member of one of the three there. So we've got the LPCB that runs the LPS 1048 scheme. We've got FIRAS and scheme, and there is now the IFC, the International Fire Consultants Certification Scheme. All three companies ensure quality of service and meeting compliance to standard. So when you are selecting sprinkler contractors for the tender, the three certification scheme exists to provide a scheme which is for both commercial and industrial, so it gives you peace of mind that they are third party and accountable. But not only that, they ensure that the contractor has demonstrated an approved QA system, that their employees have undertaken training of their staff, they have the relevant training and certification to reflect the ability of the company. So the specification should confirm that only third-party approved contractors are able to tender for the project. And finally, bottom right there, we show the Red Book Live. Sprinkler components in the UK to both BSEN 12845 and also the LPC rules must be approved components, and these are LPCB approved components that must be used on sprinkler systems to the UK standards. If you have an American standard to NFPA or FM Global data sheets, they have to be FM approved, and they have different listings, different requirements, different approvals. But within the UK, the majority of sprinkler components need to be LPCB approved, which is part of the BRE. And they have the Red Book Live website, which allows you to go onto there to look for approved components. And part of the scheme documents that you can see there for all three, you will need to demonstrate that you have purchased LPCB approved products. And to prove that, well, to understand and appreciate these, there's a link there on the screen that you can go to, and all the components should be approved by the Red Book. So, moving on to key stage 2. Once we've got the specification right, we've selected the right tenders, we know what standard we're going to work to, we know the classification of the system, we know what water supplies requirements, is it going to comply? All these little key issues we move then on to when it goes into design, installation, testing, commissioning, and then obviously the final certification. So this takes you, our stage 2, through what we accept, or what we would expect everybody to follow this path to ensure that the sprinkler system is maximised to its potential and complies. So, on the design side, does the design reflect the ambition of the system and what it's desired to do? Is it in compliance with the relevant standard? On completion of the design, have all the drawings and calculations been submitted for approval? And I'm not talking about coordination or approval from say the architect who likes the location of the sprinkler and the pipes, and the M&E consultant that says, yes, you're not hitting our pipe work. We're talking about the review of the design drawings and hydraulic calculations by a competent person, experienced person from the authorities having jurisdiction, and most importantly, the building insurer. And these drawings and calculations would, if they were submitted, get signed off for final review and inspection. Unfortunately, this is a process over the years that I've been involved with sprinklers, which is over 30 years, that has lapsed, so to speak. 30 years ago, the most important process was you sent the drawings off as soon as they were complete to the insurer for approval, and you couldn't order a sprinkler pipe or a sprinkler head until you'd had written approval, or you had some form of granted approval subject to site survey before you could go into fabrication of a sprinkler system. It's a critical process, and like I say, it's now been missed, and it leads to awkward questions and queries later in the project when non-compliances are witnessed. So if you don't involve the insurers and the authorities having jurisdictions and send your drawings off, and they get them too late, and there's an issue, and they find errors or they find non-compliances, it's more costly, and it's going to cause issues at the end of the project to get these correct. So it cannot be understated how important this process is, and how this approval process stroke timescale should be involved, and it should be involved for each and every project. And I know current limits now, when sprinkler contractors are awarded a contract, they're required on site in 3 weeks. This approval process is one of the key stages that is mostly missed, and like I say, it's one of the most important parts, because it will stop awkward questions and issues later on in the project if you involve the building insurer and the AHJs for those to approve or give you some form of approval and a review and check of the drawings and calculations. Excuse me, sorry. Installation. So once the drawings have been approved, if they do get approved, they go and fabricated, they're delivered to site, and the next process involves the installation. Again, it's another critical stage. It may change at site with unforeseen elements of building construction or a change by another contractor. How many times has a drawing been designed, signed off, gone to site, and then all of a sudden something's changed and we've had to modify the design? Therefore, part of the installation, it is important that the system is installed to the design. If there is a need for a change or modification, this should always be cross-referenced with the design engineer who's designed the system, and he will ensure that the changes comply with the standard. Many times it's happened over the years that a design's gone in and it's been hydraulically calculated, it's been hydraulically balanced, and it's going into drawing, then all of a sudden there's an issue. Something's changed and we've had to do some site modifications, and we've introduced some elbows and some bends, we've dropped down, so we need drain points, and all of a sudden we need to increase the size of the pipe. Cooperation and review with the design engineer will confirm whether these changes can be incorporated within the design that's there for installation, or may need to make some modifications to the pipework a bit further down the system, so that they can increase the pipe size to cater for the changes. So this is important. This is another important. Has it been, correctly installed in accordance with the approved design drawings? And once it has been installed, the system then should be checked and signed off by qualified, competent engineers. Any changes that have been made or modifications to the system, this is the time they should be captured, and they should be updated on drawings and sent back to the designer so that the as-fitted drawings are accurate. So the system should be snagged. It should be checked for confirmation that it meets the requirements of the design drawings, because the design drawings have been approved, and the design drawings have been approved in accordance with the specification and the standard that they are being designed to. And again, like I say, if you're using third-party approved contractors from either of the three certification schemes, they will have engineers that are qualified to sign them off and check them. And like I say, then once the drawings have been checked, sent back to the office, you've got accurate as installed drawings. Very important when we're handing the system over later on. So moving on to testing. So on completion of the installation, or sections such as the floor or shop unit, if you were to zone it, you can sectionalize test it, or you can test the whole system in its entirety. That depends on the contract, the type of building, how it's programmed to work, how it's handed over in various sections. The system should be subject to a full test regime, and as you can see on the right hand side there's different requirements for different types of system. You've got wet, dry, pre-action deluge systems. Each system has a different type of requirement. So dry pipe work needs to be tested for 24 hours. All wet pipe work needs to be tested for a minimum of 2 hours. All the equipment shall be tested. The water supply shall be tested. Sometimes nowadays water supplies are tested at the factory and factory witnessed. So the design intent of the water supply and the performance of the water supplies are captured in the design. They then get manufactured. They then go to clients and stakeholders get invited to do witness testing at the factory. When they go into site, they should be site tested and subject to a full test regimes. Again, the testing should always also be witnessed and signed off by all parties concerned. And not only that, this will also include any additions to the system. If you've got interface monitoring or off-site monitoring, interfaces with the fire alarm system, or zone checks where you're testing the flow switches, these systems should all be checked, and they should all be checked and signed off and offered to all stakeholders with an interest in the sprinkler system. Again, as I mentioned, commissioning involves all stakeholders. Prior to handover stage, this ensures the system is checked and designed to meet the requirements to satisfy the control. Now, with regards to insurers and authorities having jurisdiction, again, if it's an LPC system, you must have an insurer involved. And with regards to the insurance, there is a specific technical bulletin that's shown on the screen, which means that you must have insurer involvement early doors. The insurers need to be involved at estimating and tendering stage. It's their building that or it's going to be a building that's going to be insured. And if it doesn't comply, they need to be made aware of it. If there is some deviations from standard, they need to be aware of it. If there's areas that are non-protected, they need to be aware of it. And this is all done at estimating and tender stage. Again, they also have an impact at design stage, which is going back a couple of slides, this is where I was discussing that drawings must be signed off. Drawings and calculations must be signed off, and it's normally the insurers that would provide this. And finishing off on the commissioning part, obviously they need to be involved in inspection and acceptance tests. So they're there to witness, to prove that the system does what it's intended to do and that there are no issues. And in the event or the unforeseen event that there is a fire, the system will do its intended task. So in short, when commissioning the sprinkler system, the insurer must be involved. Also at this stage, it would be required to be issued the system specific operation and maintenance manual. Most companies have a generic. This generic manual then needs to be site specific for the risk and the building and the components that are used in that building. The system, how it operates, what it's intended to do, what the monitoring of it is, what the off-site monitoring is, who's involved in the system. These are things that must be captured in the operating and maintenance manual. And also at this stage we would include all sprinkler system signage and block plans. Final detailing is often overlooked and missing at commissioning stage. Yes, these will get put on later, or we'll do them right at the end of the project, but this information is valuable because when everybody's left the site and the building is there, this information is vital for those who have an interest in the system but want to understand it. The block plans, there's a requirement for the information that needs to go on the block plans. It needs to identify if they're zoned, it needs to identify where the water supplies are and what the water supplies are capable of and the stored water capacity. It needs to identify where the main isolating valves are or where the zone valves are. The alarm gong, what the design density is or what fire area it's protecting, and then by virtue of doing a block plan, normally coloured, unfortunately I've only shown you an example of a black and white one, but by hatch patterns or colouring it shows you the different zones and what they're being protected and where they're being protected. This information is very important, and many sprinkler inspection that I've witnessed has not got this information, and you find it very hard to understand what the system is doing and where its key components are. If for like an emergency system you needed to isolate, you would refer to the block plan and find out where there's a fire, what zone it's on, and where to isolate it. And also signage. So when the building's up and running, this should always be there. We should know where all the components are, all the critical components are. And the last part of commissioning involves questions of the contractor to ensure that the system's done. So were all the stakeholders involved in the commissioning? Was the system explained and run through by a competent engineer, more likely the project manager of the or the design engineer or design manager of the contractor? Did they run through the system with the stakeholders and explain how it works, what was involved, where they were, where the parts were? Did they provide relevant training to the site staff or the personnel involved in that system so that they know what to do? Did they communicate the emergency procedures? Sometimes sprinklers go off, they're knocked, accidental damage. A sprinkler's gone off, the pumps have kicked in. What do we do? Has this been communicated? Has the training been communicated so they know where to go, what to shut down, who to phone, and then how to get the system reinstated? And then once they've done that training, did they provide certification to those on-site staff or those on-site personnel, the engineers on site who are going to do the weekly testing and maybe monthly testing of the sprinkler system, which my colleague Ian Walters will come on to in part 3. Another thing that's critical to the certification of the system is you must have an ongoing service and maintenance agreement with a third-party approved contractor. So not only have they demonstrated the system, they've provided you with service and maintenance for maybe the first 12 months of the system. Did the insurers or the AHJs do a final inspection of the system and sign it off? You will have had, hopefully, if you followed the process through correctly, you will have had written approval on the drawings based on site inspections, subject to final inspection maybe. Did the insurer do the final inspection? Has it been signed off? Did they find any snags or slight non-compliances maybe that need to be captured and need to be altered just to ensure that it complies, so they're happy that they've got a fully sprinklered building that they can insure, and was full approval granted on completion of all those questions. So these questions are relevant to the commissioning, but the questions that I would suggest that are asked of contractors to ensure that these things are done, most of the time they are done, like I say, but just a key stage that will ensure that the system is handed over correctly. When it's handed over, so we've gone through the design, the installation, we've tested it, we've commissioned it, everybody's involved, the contractor must provide certification. Now, can a certificate of conformity be issued? Certificates that I've shown, I'm just reading at the bottom, are from the LPS 1048 scheme, and the other schemes do offer similar certificates, but just for awareness, what you would be looking for, and the Shangri-La of certification, is a certificate of conformity, and what you would prefer is a system certificate which captures the whole system. It captures the water supplies, the installation control valves, the zones, everything on the whole system covered under one certificate will give you peace of mind that you've got a fully compliant sprinkler system. However, this is not always the case. You can have some major non-compliances, unprotected areas that the fire resistance or fire rating of it doesn't comply with the standard, and it's not a permitted or necessary exception. Therefore, it could be classed as a major non-compliance. That major non-compliance will not allow a contractor to issue a certificate of conformity for the system, and on that basis then on the right hand side you can see there's a completion certificate, and that then will be issued on that particular part of the system or for the system, saying that there are major non-compliances. But again, these non-compliances should always be agreed by the authorities having jurisdiction, an insurer, which is when they are involved early doors in the writing of the correct specification. So were there any agreed deviations or non-compliances? If you've got minor non-compliances, you may still get away with issuing a certificate of conformity on the left hand side. What we want to remember is that these certificates are issued under licence by the contractor from their third party scheme providers. So they issue them. They can't be bullied into issuing them if they aren't compliant. They must be issued correctly. Now, what's changed over the last few years in the industry is you may have a sprinkler system for a building, and you may issue various different certificates. So you may get a fully compliant water supply. You may get a certificate for just the water supply. You may have a fully compliant installation. You may get a certificate for the installation. Or take a shopping centre, for instance, or an office block where it's been split into zones or shop units or floor levels. You may get a certificate of conformity for the zone if that complies, but you may have sprinkler mains running in unprotected areas, and if the loss of these would lose the system. So you don't get a full Shangri-La certificate as such. You don't get the system certificate, you get bits for the others, and then obviously for the system where it's non-compliant, you'll be looking at completion certificates. And I think that pretty much covers stages 1 and 2. I'd like to thank you very much for your time and listening to me. And hopefully you agree what the key stages 1 and 2, and hopefully my colleague Ian Walters now will try and answer any questions you may have. Thank you for your time.
Good morning, everybody. I hope you can hear me. My name is Ian Walters, and I work with Dale, and Dale's just done an excellent presentation there, so thank you to Dale. I'm going to pick up now where Dale left off. I'm going to talk about the service and maintenance and independent third-party inspection requirements of the rules. Basically, I'm going to tell you who does them, why they're done, how and when in these two parts that are remaining. I've put a sprinkler system on the screen there, a diagram of a sprinkler system for people who perhaps don't come across them every day. Obviously, sprinkler contractors are very familiar with this kind of thing, but what you can see there is a couple of sprinkler pumps and water storage tank and sprinkler pipework and the sprinkler heads. And obviously, in a big building like a warehouse, you could have several systems, but just sort of one water supply. And obviously, that water supply then is critical to the system. So some parts of the system really are more critical than other parts, and will obviously need greater maintenance than other parts. But if you look along the sort of pipework runs there, you've got sprinkler heads on the end of those ranges, and they are just as critical as the pumps themselves. Obviously, if one of those fails and the fire develops, you could lose the building in much the same way that if your water supplies don't work. So the sprinkler system itself really does need maintaining from the very start, where the water comes into the system, right the way through the pumps, the tanks, the installation control valve sets, the piping, the brackets that hold it up. Everything needs to be looked at and maintained on a regular basis. So hopefully I'll cover that in the next few slides. I've got quite a bit to get through, so I will go quite quickly. Let's not move into the next slide. Slight technical problem because it's not actually moving to the next slide here. So we're just it's gone. Yeah, it's gone. Okay. Yeah. Sorry about that. So first of all, we're going to talk about why they're required. Obviously, Dale talked about certification and certificates of conformity, and in particular 1048, LPS 1048 certificates, which are issued as part of the 1048 scheme. And it is a requirement there that for maintenance of the that certificate, that your system is maintained by a sprinkler maintenance contract for the continued validity of the certificate itself. So if you don't maintain it, you compromise the validity of the certificate. Just bear in mind that not all systems have a 1048 certificate, but where they do, it is a requirement that the system is maintained in accordance with the standard. Also, it's an insurance requirement. It's a good chance that if you don't maintain your system, then you're probably not going to be covered from an insurance point of view. That's something that you would need to check with your insurer. And it's also part of the legal requirement in the Regulatory Reform Fire Safety Order of 2005. I'm just skipping through this now, but obviously in there it does say that fire systems should be subject to a suitable system of maintenance and maintained in a sufficient state, in efficient working order and in good repair. The systems which have been designed to the LPC rules it's a requirement that they are maintained, obviously, and parts 1 and part 2 are where these requirements come. If you're not familiar with the LPC rules, BSEN 12845 is a standalone standard which specifies the design and installation of sprinkler systems. And then part 2 is the LPC technical bulletins, which are written here at the FPA and issued by the FPA and written by Risk Authority in association with the insurers. Part 3 of that document is just some supplementary information, which we won't cover today. But in parts 1 and part 2, the requirements for maintenance come from these from section 20, which covers maintenance of sprinkler systems, and section 21, which covers the periodic inspection of the systems, which I'll come on to later. Just bear with me a second. And Annex K, which covers the 25-year inspections, and Annex Q, which also covers the periodic system inspections. If you don't have a copy of LPC rules, you can obtain these from the FPA, and just let us know, and we can provide a price for supplying those to you. Within the technical bulletins, TB203 is the main one, which covers the care and maintenance of automatic sprinkler systems. It's a substantial document. It's 21 pages long, and it goes into quite a lot of detail. And I've just included the first few lines there just to read from it, because I think it does give you the overall picture, really. That a satisfactory sprinkler maintenance regime, including a thorough review of hazard, is critical to the continued dependable performance of all sprinkler systems, and that's obviously very true. So a correctly maintained one, including the periodic assessments, ensures that the system will remain fully operational at all times and is appropriate to protect the hazard. So it kind of sets out the stall there that the system does need to be maintained, and then it goes into quite a bit of detail as to how to do it. I am pressing on quite quickly, so Moving on, the sprinkler system user shall appoint a competent person. That is true. We come on to that again in a little bit, but it also tells you when within this standard when things must be carried out. And it's also it's imperative that the people carrying it out have got a good degree of competency, basically, to carry out these. So only trained personnel shall be permitted to undertake weekly testing of the sprinkler systems, and only competent companies should be maintaining the system at those intervals as well. Now, we'll go into these intervals in a little bit more detail on the following slides. But there are responsibilities on the occupier or the owner of the building to ensure that his system is maintained. So he should ensure that there is a program of checks carried out, tests carried out, which we will come on to, and these tests should be held. These should be held on the premises in the form of records, and these can be made available for review by fire safety officials and also by people carrying out audits on the system, such as during the third-party inspections. Typically, if you've got a system where you've got a sprinkler system installed, you've got a building where a sprinkler system is installed, you will probably have a weekly test log sheet where you test all your pumps and your valve sets, and you write it down how long it takes to ring the bell, that kind of thing. So the user shall arrange for the test, service and maintenance schedule to be carried out under contract by a sprinkler servicing contractor. So there are limitations to what the user can do, and then you need to turn to the services of a sprinkler servicing contractor to get the system maintained throughout the year. So the installer shall provide the user with a documented inspection and checking procedure. Will include instruction on the actions to be taken in respect of faults, operation of the system, emergency manual starting at pumps, and details of the weekly routine. The kind of records that you should have on site, as Dale explained in the first part, and it's not limited to this, but you should have as-built drawings and hydraulic calculations. And I think one of the questions that we've had come in relates to this. If you inherit a system without any kind of drawings or anything else, well, there's a few routes that you can go down to try and get them. You can approach the installing company if you know who put it in, and see if they've got it. You might be able to go to the BRE and see if you can trace the system installer, perhaps through the certification scheme. If it's 1048 scheme, you might be able to find it that way. If not, you might just have to employ a sprinkler contractor to come in and do a site survey, produce drawings, and sort of retrospectively do a calculation on the system, and get a maintenance company to come in and look at the condition of your pumps and tanks and things like that. But records should be maintained, but in the event that they're not, then you've kind of got to go back retrospectively and try and find that. And we do find quite a few projects that we look at where there are no records on site, even jobs that have been completed sort of in 2010, 2011. Sort of 10 years later, sometimes the records is one of the things that seems to disappear quite quickly, really, which is a bit of a surprise. But going back to this, obviously they've got to maintain test schedules, service reports. So when you have your pumps serviced and things like that, keep those records. And you're not talking a great deal of records here. I mean, 10 years worth of records printed out really would just go into an A4 folder, and generally speaking, unless you've got lots and lots of valve sets like a big warehouse or something like that, you're not really talking about a big document to keep on site. So it should be really quite straightforward. And the certification is very important because, as Dale said, once you've left site and issued over the 1048 certificate, really, that's all that anybody else has got to go on. If they come to modify the system or change anything to the system, things like storage and that, you can work out what densities of discharge and that you've got from the certificates. So without that information, it makes it very difficult to tell whether your modifications are actually going to comply. And the other thing to keep is staff training certificates to make sure that your staff have been trained to do the tasks. There is quite a lot of times we go to site and we find that weekly tests are being carried out, evidence that it's been done, but it's not really been done in accordance with the standards. And the reason for that is that it's kind of how we were shown to do it by the last guy who did it, really. So there's no proper sort of formal training in some instances. So it's important to keep your staff training up to date as well, and keep that in the form of records. So any modifications that you make as well, you need to keep records of that. So ideally, you'll have a set of drawings, a set of certificates, and a set of training certificates as well. So they should all be maintained on site and easy to access. So some tasks, when we're looking at who carries this out, require little specialist knowledge. So others can only be carried out by a specialist, such as a sprinkler contractor. So it's important that the appropriate staff include any security staff, because in a lot of buildings, obviously, they operate sort of from 9 to 5, so there's security staff on site in the evenings. I'm thinking perhaps office blocks and that kind of premises, or shops or shopping centres. They might be the only guys that are there on site, so if there's anything that happens at all, they should have some awareness of the sprinkler system, and they should know what to do in the case of an emergency. So they should really know the purpose of the system, how it operates in the event of a fire. I mean, they don't think that all the sprinklers go off when you get a fire. Don't forget, it's only the ones that are activated by the heat. What to do if the system operates in a fire or accidentally. If you're working in, say, a warehouse and your forklift truck driver knocks a sprinkler out in the rack, what do you do? Is it, do you need to panic, or is it something you can control easily? You need to be able to keep your sprinkler heads clear of any obstructions, obviously, because if you put storage of goods too close to the sprinklers, they won't operate correctly, and you need people looking out for that. So an awareness of the system, the people actually inhabiting the building, looking after it, they need to be clear on what to do and how to avoid the damage to sprinkler heads and the pipe work, and also the upkeep of records and documentation. So it comes back to being a question of competency, really, which I know the FPA really spent a lot of time looking into competency, really, in other areas as well. But within sprinklers, the people looking after the system should be trained and competent to do that, and that starts with the weekly activities, straight from the guy who just rings the bells every week, right through to your maintenance contractor who comes in and carries out sort of major works and services on your pumps and services on your valves and overhauling and that kind of thing. So moving on, the responsible person, once he's been appropriately trained, he or she, and certified on sprinkler system, is permitted to carry out the weekly checks, the weekly tasks and the monthly tasks. And I will be running through these pretty quickly, but then you need to go to a service and maintenance provider, and they'll be responsible for all the other routines. Now, your maintenance provider, really, you probably have a contract with the maintenance provider. It's worth pointing out at this point that you should, as the user, look at this contract, and every time you come to renew, make sure that it is current to what you've actually got there. So if you've got more than one building, or you've enhanced your system in some way or other, run through it and make sure that any changes that have occurred are written into the contract with the maintenance contractor. Sometimes what we see is, when we go along, is that a maintenance contractor might be looking after the building, and he's maybe done that for 10 years or 20 years or something, and come back. And we live in a commercial world, so these guys quite rightly come back and when they're doing a good job for you. But sometimes what we find is that they're no longer maintaining the system, A, in accordance with the latest standard, or B, in accordance with the latest layers. There might be valve sets that don't get tested, for example, by them or serviced by them, and because they're unaware of it, and also some of the routines that are in the rules, such as review of hazard, that is one of the requirements of the standard. It's not always carried out, and sometimes that can be in the contract, when you look at it, either omitted or actually excluded by the contractor. Now, the contractor can put forward a contract to the user, and it might be accepted by the user, but the user is not the expert. You are reliant on the contractor. So I think you need to make sure that you're getting what you think you're getting, and they think they're providing what you should be getting as well. You don't want any gaps in there where the clauses of the standard are not being maintained, because that might invalidate your insurance and and also lead to the system itself not being maintained properly. So it's very, very important that you don't just renew your contract. Have a chat with your maintenance contractor, ask them, they're the expert, and if they're not, if all clauses in there, the maintenance requirements of clause 20 and TB203 are not in the contract, you just need to establish, are they relevant to your system, and if they are, you should make sure that they're actually written into the contract, or you take steps to get them addressed in some way. So I'm just going to look at the checks now. We've listed them all out, sort of weekly, monthly, quarterly, 6 monthly. Generally speaking, these are taken from TB203. Clause 20 is very, very similar. And if you apply the LPC rules, obviously TB203 actually supersedes the requirements of clause 20. But I do mention that because clause 20 is a standard in its own right, if you just choose to adopt that standard. But from a weekly point of view, this is the in-house check. So somebody would check the pressure gauges, the water levels, and the correct position of all the stop valves. They're just checks, and they should be recorded onto a weekly sheet. Then you need to test and record things like the alarm gong sounds of your valve set once a week, and then start and run your fire pumps. So if you've got 2 fire pumps, you need to run both of those. You need to check the correct function of the trace heating systems, And importantly, check that the transmission of any alarms to any off-site local fire and rescue service or central alarm stations is also functioning correctly. And all this needs to be written down, and depending on the size of the system you've got, this could be quite a simple system. I mean, you might not have any pumps, you might be a town's main fed system, so you might just have a valve set coming straight off the town's main. That might, might be a couple of minutes every week just to do that. Or you might be in charge of a big warehouse where you've got 2 sets of pumps and tanks, or 3 sets of pumps and tanks around the site, and you could have 50 or 60 valve sets. So it might be a small undertaking, it might be a big one, but either way, whatever it is, it needs to be written down. And generally speaking, if you've got, say, 10 valve sets, you'll probably have 10 weekly test sheets, one for each valve set that you've got, just as a rough guide. Obviously, circumstances are different for everybody, but the important thing is that this could be carried out by your in-house staff as long as they are competent and have been trained to do so. The monthly things to look out for really relate to the tank and the batteries. Just check the batteries are level and check the water levels and things like that, and check the ball valve security. We do come on to this a little bit later on, but just check that your ball valve is secured and locked, and nobody can just get up there and put things into your tank. And again, this can be carried out in-house, and you don't have to get a specialist contractor in for that, as long as you've got people in there who are trained to do so. In terms of training the staff to do these tasks, if you've got a good relationship with your maintenance contractor, you could ask them to train you on a weekly basis. I'm sure you could come to an agreement there, or perhaps even pay for it, or you could come to somebody like the FPA and get some training from such as ourselves, and we'll show you how to do it. Obviously, we run training courses to demonstrate how this is done. So now moving on to the activities which must be carried out by a specialist. These can't be carried out by in-house staff. This would have to be a maintenance contractor, and your maintenance contractor, really, as Dale said, you should be looking at somebody who's sort of LPCB approved, or LPS 1048 approved, or FireS approved, or IFC approved, some other scheme that demonstrates competency to be able to do this. And maintenance should really be part of their approval to enable them to carry this out. So on a quarterly basis, flow switches need to be tested, and obviously if you've got something like a multi-storey office block divided into zones with a flow switch on each one, if you've got a 60-storey building and there's 4 on each zone, that would be 240. It can be a laborious undertaking, but it needs to be undertaken by a specialist. It's not something you can carry out in-house. I did mention earlier on review of hazard. This is very important. It is one of the things that often doesn't get carried out. It's one of the things that we've seen during our independent third-party inspections that we carry out. There need to be 4 per year. That's 1 every quarter, 3 of which, depending on the kind of business that you've got, could be undertaken by the owner or occupier in the form of a checklist. But the final check must be undertaken by a suitably qualified, competent person from the sprinkler contractor. The reason for this is during the operation of a building, obviously things like the usage can change. You could add new buildings. There could be things like, have you had it painted or decorated? Have you changed the way your occupancy? Are you making a product now that you weren't making before? So the layout's changed. What you're storing on site has changed, the way that you're storing it. All these factors have a big bearing on what the sprinkler system was originally designed to do. So when Dale was talking about ordinary hazard group 1 systems, obviously they're to cater for a fairly sort of light fire load, such as, for example, a school. Ordinary hazard group 3 system could be something like a shopping centre or some production areas. But if you've got like storage and that, then you're into high hazard. And if you've got something like a shopping centre and with the storage area, does that then fall into ordinary hazard, or does it become high hazard? So if you build a warehouse into your retail unit because you're storing lots of goods, you might be taking it from an ordinary hazard category into a high hazard. And somebody should be carrying out a hazard review just to look at this kind of thing and make sure that the system that you've got there still complies. Complies on a practical basis. Make sure that you haven't done things like put ceiling in, which has gone underneath the heads. We've seen that happen. So the heads have hit the roof level and they're completely blinded now by the sprinklers, by the ceiling that's gone in underneath them. People have started to store things higher than was originally envisaged when the building was first built. Have there been any alterations to the sprinkler system? Any of this nature has got to be flagged up on a quarterly basis, and that is one of the things that we noticed hasn't been done. So I'm just going to click on, and so I've got a number of pictures which are going to come across the screen now. That was storage there. We saw a storeroom where originally storage was on the shelves, but people have started to store things onto the top shelves. So basically what's happened is there's no clear space between the sprinklers at roof level, and obviously the sprinklers are blinded and they won't operate, or they'll operate slowly, or the water spray discharge will be affected. So it clearly needs that top level of sprinklers, top level of boxes need to be taken off the shelving. We saw sprinklers where services are being put beneath the sprinklers installed, so it's kind of obstructed it. This picture is a room which once was an office, it's been converted into a TV studio, so you've got lots of electrics and other things in there now. It was never designed as a TV studio, so it's ordinary has a Group 3 system, which really should be an ordinary has a Group 4 system now. Bearing in mind it's got lots of electrical cables, little sort of TV sets, lots of combustible materials. And just by chance in that particular building, lots of combustibles stored in there as well. So obviously, things like that would be flagged up on a review of hazard. This fourth building, this is a case of overspacing. That building has been in for a long time, and probably maybe 20 years, and the heads near the windows there are well overspaced. The maximum spacing for ordinary as a Group 3 is 12 square metres, and these are spaced at something like about 20-25 square metres. So even in an old building that's been there and presumably been insured for a good many years, you still find that the original installation might not have been put in there quite correctly. So we've gone along and done a third-party inspection, flagged that up, and then steps should be taken then to relocate those sprinklers into the correct locations. The fifth picture on there, you can just see a glass partition in the bottom left-hand corner which has been put in, and beyond that is a sprinkler head. The glass partition's gone in after the sprinklers. It means the sprinklers on this side are now too far from the glazing. They're probably about 2.5 to 3 metres off that glazing, so they'll be pretty ineffective in that part of that building. And that should be picked up by a review of hazard. It should also have been pointed out by sprinkler contractor going in and doing a quarterly review of hazards. Just have a look and say you've got a petition there which is blinding these heads. He might not have been aware that that petition had gone in, but certainly the building user would. And if the building user had been trained into what the sprinkler system was there for, he might have just been able to say, we're going to put a petition up, do we need to relocate the sprinklers? Because they would probably have relocated lighting and other things, and doors and all the rest of it to accommodate it. Sprinklers also need to be considered when you do that. And finally, on this particular slide, we've got a hazard chemical cupboard there, which had been put into a sprinkler pump room containing lots of flammable materials, actually in a sprinkler pump room. So if you get a fire in that particular instance, well, that would potentially wipe out the 2 fire pumps that are there to protect the building from fire in the first instance. So it's not good practice. It needs to be moved, and it is dangerous. And that kind of thing, obviously by hazard review, would be picked up. So that's just a few little examples across that particular screen there. And that was on a quarterly basis, can only be carried out by a specialist. So 6 monthly, obviously your alarm valves and your stop valves need to be operated and checked, and any changeover from alternate systems, when you change from a wet system during the summer to a dry system during the winter, that would be done on a cyclic monthly basis. And all your stop valves controlling the flow of water to the sprinklers should be operated to ensure they're in working order. This includes any subsidiary zone valves. So going back to my earlier example of a building multi-storey office block where maybe you've got, say, 60 floors, you think of something like, say, for example, the Shard in the middle of London. I don't know how many zone valves are on that, but there's probably going to be at least 2, 3, maybe 4 on the floor, about 60 stories high. So you've probably got 200 zone valves in that building, I should think, at least. It can be quite a laborious thing to be carried out. So it does need to be carried out by a specialist in any case. And don't forget, all this needs to be recorded. 6 monthly, the water supplies need to be tested, whether that's a town's main test through what they call a proving pipe, which is shown in the picture on the left there, or if it's a pump and tank, you need to test it using a test return pipe work, such as that shown on the picture in the middle there. If it's a pump system, you'll be looking to produce a pump curve, similar to the one that's on the right-hand side there, that curve. And if you do this on a regular basis, as required by the rules, if you do plot one for each of your pumps, what you'll find is that you'll be able to tell whether there's any kind of deterioration in the system over a period of time. Now, obviously, you've got to maintain having the systems serviced on a regular basis. And so you should be able to pick this up, but what you don't want to find is that suddenly your pumps are performing below duty, particularly if they're well, in any circumstance, but if they're special pumps where they're done for full hydraulic calculation and certain duties that you need to meet, or pre-calculated where you've got a nominal duty on the pump curve, you don't want those pump curves dropping down below the curve. You want to try and maintain a little bit above so that the pumps have always got just a little bit in hand. Moving on. Obviously, the annual service, and these annual services incorporate everything else as well. You've still got to do all your weeklies and your quarterlies if they fall at the same time as the annual. You don't not do the weeklies on the annuals in 6 months. You've still got to do them every week. But there's a lot of requirements there. I'm not going to read them all out because they are in TB 203, which you can get a copy of from Risk Authority website. By the way, I didn't point that out, but you can actually get a copy of that and read through that in some detail. But on the annual service, it must be carried out by the specialist. But on this one, you can see things like the visual integrity check of the condition of the pipework and the pipe supports and sprinkler heads, things like that. So sprinkler heads, in the middle there, you can see a sprinkler which is damaged and dirty. Now, being dirty might not stop it from operating, but the research shows that it will inhibit it. It might well slow it down, and it might prevent it from operating, depending on what it's got coated with. In the event of this particular sprinkler operating, the deflector is damaged in any case, so the water spray discharge from it might not be very effective either. So sprinklers should be checked on a regular basis, at least on an annual basis, and any damaged or dirty heads should be cleaned or replaced, and that does require a specialist. That's not something you can carry out in-house. Pipework supports often get overlooked, but it's important to look at your supports. I mean, if they're rusting away or they're damaged, if you get a sprinkler system operating, there's a good chance that when the fire pumps kick in, these operate with quite a jolt because they're operated on pressure. So the electric pumps and diesel pumps kick in very, very quickly. The pressure builds very, very quickly. So if your pipe supports are not up to speed and not capable of taking the shock loadings, then you could find your pipework on the floor and water going everywhere other than onto the fire. So you can read all the other requirements there. These slides will be available after this presentation, so you can have another look. So we won't go through every single requirement there, but there are annual requirements which are required to be carried out by a specialist. So the annual third-party inspection obviously is something that the FPA can do, and other bodies do it as well. The sprinkler inspection should be periodically inspected by a qualified person at least once a year. The inspection report shall assess whether the sprinkler system is in accordance with this standard with regard to, but not limited to, the maintenance, operation and adequacy for the risk. So where appropriate, a list of deviations shall be issued for action. So the criticality of each action shall be identified. And the way we do that is we provide a report, and if something's really critical, we identify it as red. If it needs action, well, it's not going to result in a system failure, so to speak, we sort of flag it up as an amber. And if it's something that's obviously there that should comply with the system, but probably isn't going to make the system fail, or say for example some missing hydraulic notices or some missing block plan or something like that, we might sort of flag that up as a green and say, look, you should really have this, try and get hold of it. It would make it better if it was there. The sign that you've got says it's a sprinkler pump ring, for example, but it's not clear where the valve sets are done. We kind of flag that up as green. If you've got a problem with your water supplies, I'll just give you a typical example of something that's red. We look at your report and see that the system, your pumps aren't working, or your pumps are below duty. That will be flagged up for definite as a red, because obviously if your pump doesn't work or your water supply isn't capable of meeting the requirements, then it doesn't matter how good the rest of your system is, it's not going to operate correctly in the event of a fire. If you've got things like a bit of overspacing here and there, we might raise that as an amber, depends on the criticality of it. If it's just one room, if it's sort of generic through the project that they've all been overspaced, that would be raised as a red, because obviously your system wouldn't be fit for purpose there. If we found something like an ordinary hazard, one system had been installed into an ordinary hazard group 3 system, we'd raise that as a red, because obviously the system wouldn't be capable, or wouldn't have been designed and installed to meet the requirements of the system for the classification which was appropriate. So red, amber and green is the way that we identify the criticality. The periodic inspection should be undertaken by an independent body. It's not the system owner, it's not the building occupier, not the system installer or a competing installer, or the service and maintenance provider or a competing service and maintenance provider. It's a bit of a mouthful there, but the idea is that the inspection is carried out by a completely independent third party who's got no interest other than to make sure that the system complies with the standard, whichever standard that is, which was covered by Dale earlier in the webinar. The reason is that first of all, as a contractor, it's not fair that you can't mark your own homework, because if you put a system in and you put it in wrong, you're really not going to flag that up. Everybody makes mistakes, but you can't really mark your own homework. The other thing is that if you're marking the homework, so to speak, or you're looking at and inspecting the work of others, if you're commercially trying to win their work, then again, you've got a vested interest in kind of painting it blacker maybe than it needs to be to the in the report. For your own commercial ends, whereas an independent third party doesn't have those financial incentives to do it, and also can look at it sort of with the clean slate, as it were. So it's very important that this annual third party inspection is carried out by an independent third party, and it can't be carried out by any of those people there. The insurer aspect of it is the insurers do a great job doing checking the buildings, but they're not necessarily checking everything on the sprinklers in as much depth as perhaps an independent third party inspection of a sprinkler system. And also, if they see something that perhaps doesn't comply fully with the rules, they can take a view on sort of how much whether or not to charge the full premium, or perhaps increase the premiums, or come to some agreement with the user. Whereas the independent third party is looking, does it comply? If it doesn't comply, why doesn't it comply? And what is the criticality of that? So, yeah, it's very important that you actually get your third party independent inspections carried out on an annual basis, and that is a requirement of clause 21 of BSEN 12845 and TB 203. I'm moving on here. I'm conscious that I'm kind of going over the time limit here, so if you're sticking with us, thanks very much for doing that. The 2 yearly, there is a 2 yearly requirement in there, which is in TB 203, and that is to undertake a service of the pumps. TB 203 table T2 gives quite a detailed sort of list of requirements of pump servicing. It doesn't actually cover everything. What you need to do is get a sprinkler pump specialist in to carry out some of the servicing of this maintenance contractor. You can organise that with your maintenance contractors. Some maintenance contractors have the specialist knowledge, but what you need to do is look for the competency and training records if you are the system user. So there are 3 yearly checks, and there are going to be 5 yearly and 10 yearly coming up. On this particular page, you've got 3 years and 5 years. So if you've got a 3-year tank or a 10-year tank, your 3-year tank would need to be drained and cleaned as necessary. The difference between the 3-year and 10 years is when you purchase the tanks at the time of installation, you'll purchase either a 3-year tank or a 10-year tank. And a 3-year tank is free from maintenance for 3 years. In broad terms, obviously look into the rules and get the full definition, but a 10-year one is free from maintenance for 10 years. So they're slightly different. If you bought a 3-year tank, your system's been provided with a 3-year tank, when 3 years is up, you need to train it, clean it, get it examined internally and externally for corrosion and fitness with purpose, and have any fabric attended to as necessary to look inside it. Those 2 pictures on the left don't necessarily represent 3 years and 10 years, by the way. They're just pictures just to show sprinkler tanks. And then the 10-year tank, after 3 years, you need to inspect it, and you could use the ROV camera equipment, just a submersible, just to pop in there and have a look. If you can get good pictures from that, that might be satisfactory to satisfy yourself that the tank doesn't need to be fully overhauled at that stage. I'll come back onto the tanks in a little while when we get to the 10-year, but the guarantee on a tank is not the same as 3 years and 10 years. So although you buy a 10-year tank, it doesn't come with a 10-year guarantee. It comes with a 12-month guarantee, which is a standard purchase warranty like anything else that you buy. Just point that out. After 5 years, things like dry pendant heads and multiple controls, they should also be, a sample should be taken out and sent away for testing. For example, to an independent test house. I know the FPA can do it, other people may be able to do it, but certainly if you've got them in, you can send them here, and we test well, probably hundreds of heads a month, I should think, maybe even a few thousand heads a month perhaps. So they need to be sent away, but just be aware that some manufacturers might require more frequent testing. So depending on what's been installed in your premises, that might be every 3 years, might be every 2 years. you need to check and look what your manufacturers actually say. This is the 10-year, talked about 3 years. After 10 years, your 10-year tank needs to be fully overhauled. It needs to be drained, cleaned as necessary. It needs to be examined internally and externally for corrosion. And the idea is that a tank refurbishment work should generally aim to restore the tank to the condition and structural integrity that it was installed to originally. So that's quite important there, really, because you need a specialist to come and look into the tank. And a lot of tanks have liners, a butyl liner inside. And what you must avoid doing is, if you've got leaks from it, if you haven't got a liner in your tank, if it's not that kind of tank, putting a liner in is not necessarily, for example, a solution. You might need to replace the whole tank because the integrity of the tank might have gone, and with it, its structural soundness. Don't forget, water is very, very heavy. It's a metric ton per cubic metre. So when you've got a big tank of water there, that is containing an awful lot. So it does need to be a very, very strong tank, and it needs to be in a good condition. You don't want it collapsing. That brings me on to the 25-year. So we're almost at the end now. We've got 25-year testing. The idea here is that you should flush your system through until the water runs clear, and then you should check internally and externally the condition of the pipework and the sprinkler heads. The sprinkler pipework, what you need to do is actually take some sections out, have a look in the pipe. If it shows any signs of any pitting or anything else, or corrosion, or is rusting away, take some pictures. Those examples on the right hand side there, they give you an example. Not very nice to look at, but they are the extreme. Quite a lot of times you look inside a sprinkler pipe, it's actually not too bad, to be fair. But equally, if you do find this, there could be reasons for it. It could, of course, be that your pipes are in a corrosive atmosphere, or the processes beneath it which are corrosive. You need to check that. Just by way of what I said earlier on as well, if you look at the central picture there with the pipe and the bracket is actually rusting away just as much as the pipe there. So you must look at all of these things, but obviously look at the brackets more often. 25 yearly, you need to be looking at taking some of the pipe work out and sending it away to a specialist test house. Again, I keep saying we're the FPA, but we do all these things. So if you've got pipes, you can have them sent here. You'll need your maintenance contractors to take them out, or a specialist contractor to take them out. Obviously, they'll need to replace what is taken out with the new stuff, new pipe and possibly new brackets and new sprinkler heads. In the same vein, it is a requirement for the sprinkler heads to be tested. There's a sample here. You can see various sprinkler heads where they've been overpainted and things like that. These are some of the heads that have been sent into the FPA. Some barely recognisable as a sprinkler head at all, to be honest. And these are the worst case. I mean, most of the sprinkler heads that get sent in, sometimes even the very, very old ones, they pass the test, so that's the good news. The sort of sampling that you're looking at would be defined in the table in Annex K and TB203. Generally speaking, most of the sort of batches that we receive tend to be within that sort of 20 sprinklers. So normally you send 20 in to the FPA for testing, and a report is produced. And obviously, if they fail, then you might have to replace the sprinklers in your premises. But in a lot of cases, they do pass. But that is a requirement. That's the maintenance requirement that you need to get done after 25 years. So I'm going to finish off now, really. And like I say, thanks for sticking with us. We have overrun a little bit, but these are the kind of things that we find during our independent third-party findings, and which flag up, and then the system user corrects. It's not everything, it's just a sample of the things, but obviously maintenance records, we find there's quite a lack of records, often in projects that are not very old, maybe sort of 10 years old. For some reason, the as-built drawings have disappeared, the certifications disappeared, or it's incomplete and inconsistent. When Dale was talking earlier on about the 1048 certificates, we find sometimes that the non-compliances haven't been listed, or things like that, which is obviously a problem. It should be done. So the maintenance isn't fully carried out in compliance with the standard. So, for example, review of hazard isn't carried out. That's one of the common things that we see. But sometimes not all the testing regimes are followed. Water supplies aren't tested regularly enough. That kind of thing. Quite often there is a lack of client awareness of the requirements for maintenance, and just generally a lack of client awareness of the sprinkler system. So I mean, in places like shopping centres, a lot of the shopping staff, for example, have no idea what the sprinklers are. They think the fire alarm system is exactly the same as the sprinkler system, and there are big differences between the two. Lack of training for people who carry out the in-house tests themselves, the weekly testing of the pumps, and that we've always done it this way, or we've been shown how to do it this way. So bad habits kind of breed bad habits. What you need to do is have a refresh, get yourself trained up again, and then it'll make sense, really. I think a lot of times you see people do like a tick box exercise where they read a couple of pressures, put them down, or maybe even write the same pressure down that they had last week without checking the gauges. Very important that the staff trained to do it know exactly what they're doing, what they're recording, why they're recording, because you rely on this system in the event of a fire. And if it doesn't work, it could well be because it hasn't been maintained correctly. Systems have been installed incorrectly. We've seen lots of overspaced heads, as you can imagine. Not always down to the sprinkler contractor, of course. It could be that petitions have been taken out, or the building's been changed, or for one reason or another. Systems have been incorrectly installed. Sometimes we've seen where there's been OH1 systems and they should really be organised as a Group 3 because they contain lots of storages. Hazard reviews not carried out, we've already covered that. Water supply is not being tested, pumps not meeting duty. That's obviously a critical nature, and we do see that from time to time. The other one, of course, is water supplies where you've got a town's main fed system. It's important to test those at times of peak demand, and so that you know that when everybody's sort of running the taps at the same time as there's a fire, that you will have enough water coming into the system to put fire out. And that's not always the case, to be honest. So you need to test them, and also you need to test them if you've got duplicate water supplies coming in from a town's main. You need to test them one at a time and not both together to make sure that if one of them is isolated, you've still got enough water to meet the requirements of the system. So I've just covered that. Sprinkler heads being overpainted and damaged, particularly with concealed heads. This is where you look up to the ceiling and you can see there's a sprinkler head, but it's just a flat plate that you can see. Once these have been overpainted, then there's a good chance that they won't operate because first of all, they won't detect the fire quite as quickly because obviously you've got a layer of paint covering it, and also secondly, by the time it does come to operate, the layer of paint might actually just be holding the cover plate on, which means the head might operate above the ceiling, and then if it doesn't drop down below the ceiling, obviously you're going to lose coverage in that area. So things like that, you've got to be checking for that kind of thing. But if you get any kind of paint on the sprinkler head, then that sprinkler head should be replaced immediately, and that should be picked up on a hazard review on a quarterly basis. We've been to premises where the usage has changed, and they've changed from office to TV studios in some areas. We've got storage methods which have been changed. We've got in warehouses, it's quite common that you'll see that where you've got beam pallet racking, for example, the beam pallets will be moved up a couple of notches on the uprights, and then means that the sprinklers which are running down the central flow spaces are no longer in the correct positions and would be ineffective in the event of a fire. So that's the kind of thing that you need to look out for. And obviously, I gave you an example earlier on where they put new partitions up. Sometimes putting up new partitions means you're blinding a sprinkler, and also means that the sprinkler on the other side is too far from the partition. So you need to relocate your sprinklers. So if you do any works, obviously run it past your sprinkler contractor and get that checked out. And we've been to warehouses where there's new storage racks being installed, fully sprinkled building. They put a couple of new racks in and not put sprinklers in there as well. Basically, if you get a fire in those, it will overwhelm the rest of the system. And once it's actually started, bear in mind the sprinkler system there is to operate immediately in the event of a fire. If you've got a fully developed fire, it's going to be very, very difficult to guarantee that would put a well-developed fire out. And finally, we've been to systems really where the maintenance contractors haven't got really much in the way of any kind of accreditation ready to carry out maintenance on sprinkler systems. They're more likely to be alarms companies who kind of convince the user that they can do the servicing on the sprinkler system as well. The LPS schemes, for certain, and maybe the IFC and fire schemes, all have their own maintenance requirements of companies. As a user, you'd be well advised to look into that and make sure that the people coming to service your system do have the competency, can provide the certificates of training that they can use these systems. It's very important. It's too late when your system's a pile of scrap on the floor because you've had a fire. Take action now, and that's my final slide. And I'm rushing through this, and again, thank you because I have overrun. There are 4 pictures there of tanks. You can see, obviously, looking inside the tanks, the kind of things that you find. In the first one, obviously, the ball valve housing is badly rusted up there. And in the right-hand one, something's actually grown out of it. Looks like a garden has grown out of it. But in the middle there, the vortex inhibitors have basically dropped off the pipes there. So the pumps may not operate properly, or other things might be sucked into the suction pipes. This is a picture that's provided to me. This is the kind of thing that drops in, people put into your tank if you don't address the security of your tank. If you look at that, it is a requirement that you check the ball valve on your tank on a weekly basis. On a monthly basis, the security of it. You can see all kinds of things have been dropped in there. Now, at the bottom of that picture, you can actually see the pump suction pipe. So that is where the water would be sucked into the pump in the event of a fire. So normally that tank would be full, and that pipe, when it comes to the wall, has got a vortex inhibitor on the bottom to ensure that water flows in nice and smoothly. To the left there, you can see somebody's dropped something that looks like a parasol. If that got dragged into the vortex inhibitor and then up the suction pipe into the pump, it would jam the impellers on the pump, or potentially jam them, damage the pump, maybe even wreck the pump completely. Certainly inhibit, or perhaps even prevent completely the water from that tank going into your system and putting a fire out. So it could be what's in that tank there. It might even just be a bug. One of the wheels of the buggy might get dragged in and take out one of your sprinkler pumps, either your duty pump, your standby pump, or if it's the only pump you've got, it would completely negate your system. So it's important that your tank doesn't end up in that condition. Two pictures to go. This is the kind of thing that we find on a inspection. That's a flexible arm pipe to a sprinkler head. You can see there that somebody's kind of, well, first of all, there are manufacturers' recommended specifications on how it should be installed. That doesn't meet any of them because it's not been installed correctly. But equally, it's been tied up. It could have been done by a sprinkler contractor, maybe, or it could have been done by somebody else. Whoever did it, it's an unacceptable situation. It could well be that because it's flexible, it's been moved out of the way, and somebody like an electrician or a lighting man has come along and just sort of wired it up out of the way and then put it back in afterwards. That kind of thing, really. If you have any work done, the sprinkler contractors at the time of handover, their work gets snagged. As Dale said, the work is snagged, so it wouldn't be left in that condition. But if you have any work done, make sure that whoever puts things back puts them back correctly and doesn't leave them in that condition. Because if that sprinkler head operates, it's a good chance that it will just be ineffective. The head itself might actually be above the ceiling. It's difficult to tell from this picture. So, and finally, what that shows there is a storage rack, which was a sprinkler rack, all well and good. But there they've stored a lot of pallets, idle wooden pallets, which is a very, very high fire risk. It's got its own TB. The number just slipped. The number of the CB has just escaped me for the second, but it is in the TBs there. But common thing that you see in warehouses is that goods are delivered on pallets and then they're transferred to racks. Those pallets with that high fire load are too high a risk for that particular warehouse. A fire in those pallets, even stored just 2 or 3 pallets high, could well overwhelm the system and sort of spread to the rack, overwhelm the sprinkler system, overwhelm the roof system. So things like that would be picked up by review of hazard. That just gives you a few practical examples of the kind of things that we've come across, and the importance of having a review of hazard, an independent third party, and also maintaining your system. Just to let you know, this is the final slide. The FPA and Risk Authority are in the process of actually producing a service and maintenance booklet which gives details of best practice. This will be available to download from the FPA Risk Authority website, and that's expected to be issued in June 2021. As far as I understand, it is a free document that's going to be issued. Don't hold me to it, but if you log on sometime soon. If you are a member of the FPA, you'll probably get an email anyway. If you're not a member of the FPA, it's well worth joining anyway, just a little sales plug there. But thanks very much for listening.